This video is going to explain how to expand and condense logs. It works for natural logs as well. They're pretty much interchangeable. You may remember seeing this chart from my last video. I brought this up again so that you can really see that one side of these equations are condensed. Okay, so this is considered to be condensed, that's considered to be condensed, and that's considered to be condensed. Okay, so let me write that up there in red. Condense. Okay, versus these others over here in green, which are considered to be expanded. Okay, everything over here in green on the right is considered to be expanded. All right, so you will be asked, you'll be given one version and asked to put it in the other form. Okay, so again, you can write this down. Maybe you have it from yesterday. You can always rewind the video to look at it. But let's see how this goes. Okay, so this is a picture out of the textbook. So I'm trying to expand this. All right, so since this is being held together with multiplication, when I go to expand it, I'm going to have two completely separate logs, and they're going to be held together with addition. Okay, so both of these logs are going to be base 10. Log base 10, log base 10. Now, the two things that are actually being multiplied, one of them is going to go in the first blank, and the other one is going to go in the second blank. Now, you do have to look at each of those blanks and see if they're simplifiable. All right, so for example, on this first one, this is asking you 10 to what power equals 10? And that's just 1. And then over on the second one, right, I don't know what z is, and so I can't do anything to simplify this particular log. So I'm going to write that as just log base 10 of z. All right, let's move this up. Example number 2. All right, and again, the directions have not changed. The directions are to expand. So right now, you can see that this argument is being held together with division. It is y divided by 2. So when I expand it, I'm going to hold those together with subtraction. Again, you can look at that rule in the chart at the beginning. These are both going to be log base 10 because we started off with log base 10. And then the first or the top argument is going to go first, and the bottom argument is going to go second. And then again, just kind of ask yourself if either of those is simplifiable, which they are not, so that is your answer. Scooting it up for number 3. All right, so if you look on that chart, you'll see one that says the power property, all right, and it says that I can take this exponent and put it out in front of the log. And by doing that, you end up with an expanded version of the exact same log. That's it, that one's done. All right, the only thing I have to do on this one is I'm going to rewrite this. I'm going to take this out of radical form and write it in exponential form. So I'm going to write it as 1/3. And then I'm going to use that exact same rule that I used on the last example, where I'm going to take that exponent and I'm going to put it out in front of the log. And that is considered to be expanded. All right, and then this one. All right, if you'll notice in this argument, again, sorry about that, I am looking here. There are 3 different things in here. There's an x, there's a y, and a z. The x and the y are being multiplied. So that's why I have this plus in between these 2 blanks. But the z is being divided. So that's why I've got a subtraction as well. All right, now these are all going to be natural log, natural log, natural log. The 2 things that get multiplied go with the pluses, and then the subtraction, right, the thing that is being divided, goes after the subtraction sign. All right, so now notice the directions have now changed. Now the directions, again, you're looking way up at the top here, they say condense. Right now I've got 2 logs. By the time I am all done, I want this to be a single log. Okay, so I might as well just write that down. There's my single log. Okay, all you have to do is ask yourself, what is holding these two things together, right? And they're being held together with addition, right? When I go to condense, that means down here, those two things are going to get held together with multiplication. I just erased the wrong thing. Sorry about that. All right, so because of this addition, these two arguments are going to get held together with multiplication. All right, let's try another. Again, the directions here are condense. And so I see subtraction, which means I'm going to have, after my log base 5, I'm going to have division. Right? Subtraction equates to division when you condense. The first number is the number that goes up on the top, and the second number is the number that goes underneath. Let's try another condensing. All right, now this one has a number out in front of the log. All right, what that means is if I'm trying to condense, I just have to make that into an exponent. So I'm going to have still log base 7. The argument is not going to change, and I'm just going to have an exponent of 5/2. All right, this is my last example. All right, so the first thing I'm looking at here is I see that this 2 needs to be made into an exponent on that x. So let me start condensing by doing this. All right, so now I have 2 natural logs, all right, that are being held together with addition, which means when I go to condense that I am going to have to multiply, the 2 arguments that we had before, which would be x squared times x plus 1. That is that log completely condensed. All right, as far as I know, oh no, I'm lying, there is one more. Okay, so I'm going to approach this sort of the same way I did the last one. I'm going to take this 2 right here. I'm going to write it as an exponent. So I have natural log of x minus the natural log of x plus 2 squared. Now, because these 2 natural logs are being held together with subtraction, when I go to condense, I'm going to be holding the arguments together with division. The first argument is going to go on the top, and the second argument is going to go down below.